In this video, we are going to work the following problem. It says find the intervals on which f is increasing and then also decreasing. And the function we're given is f of x equals -8/3 x cubed minus 55 halves x squared plus 7x minus 8. Okay, on these problems, it is a good idea to go ahead and figure out the domain of the function that you're given. So this is really easy. It is a polynomial. And the domain of every polynomial is minus infinity to infinity. Okay. Next up, right, in order to answer the question, right, where is this function increasing, where is it decreasing, what we're going to have to do is to solve the inequality f prime of x is greater than 0. Okay. So that will directly give us the solution where f is increasing. Okay, and then also when we do the work to find this, we'll also be able to figure out where the original function is decreasing as well. Okay, so in order to solve that inequality, first off we need to take the derivative. Looking at this function, it is a polynomial, so using the sum and difference rules, all we need to do is to take the derivative of, since it's all expanded out and all the terms are added and subtracted, right? We can just take the derivative of each individual term and then add or subtract those as the case may be. So looking at the first term, -8/3 x cubed, we're going to use the constant multiple rule, right? We have a number, a constant, times a function. So the constant multiple rule says to rewrite the constant and then multiply by the derivative of the function part. That is a power function x cubed, so the derivative of that would be 3x squared. Right, bring the power down and drop this power by 1. Next up, we'd subtract off, using the difference rule, the derivative of this term, 55 halves x squared. Again, using the constant multiple rule, right, we would rewrite the constant, which is 55 halves, and multiply that times the derivative of x squared. That is a power function, and using the power rule, right, the derivative is 2x. Then the sum rule says add the derivative of 7x. Okay, so again, using the constant multiple rule, that would be 7. I would rewrite the constant and multiply by the derivative of the x, function x, which is just 1. And then I would subtract off the derivative of 8. 8 being a constant, its derivative is 0, so I'm not going to bother to write that there. All right, so we have the derivative. What we need to do next is to simplify it as much as possible. So -8/3 times 3 is going to wind up to be -8x squared. -55 halves times 2x is going to be -55x. And then plus 7. All right, so here's the derivative completely simplified out. And so what we would do next is to solve the inequality, right? So -8x squared minus 55x plus 7 greater than 0. All right, so that is a quadratic inequality. It's a nonlinear inequality, so you can't solve that the way you solve a linear inequality. So what you would have to do, or one way to do it, the way I prefer to do it, is just to solve the corresponding equation. So this is a quadratic equation. All right, and so we can solve this quadratic equation. So this equation looks like it can be factored, right? If I look at -8 times 7, that's -56, right? So I would need two numbers that multiply to give us -56 and then add up to give -55. So that would be -56 and a +1. So that means that this equation is going to factor, okay? To factor this one, I would prefer to go ahead and factor out that negative sign, although with some methods you can use to factor, you can just leave it in there if you want. So you use whatever method that you're used to using. All right, So factoring out this negative sign gives us positive 8x squared plus 55x minus 7. And this is going to factor into two binomials. All right, so we need two numbers that multiply to give us a negative 56, right? But add up to give us a positive 55. So that is going to be negative 56 and a positive 1, all right? Just quickly looking, right, we know that 7, it's only going to break down as a 7 and a 1, right? Because it's prime, right? So if it factors, it's going to have to factor looking like this. And then because of the numbers that we need, this is going to have to be an 8x, right? It was negative 56 and a positive 1. So our that's what we need to do that, to factor this thing. Yeah, and actually, right, it's going to be 56. We need two numbers that multiply to give us negative 56 and add up to give us positive 55. So that will have the 56 will have to be a positive, right? And then, so that means that this is an x and this is a minus 1. All right, so let's just double check that to make sure everything looks good there. And so multiplying that out, I get 8x times, or x times 8x is 8x squared, right? And then 7 times 8x is 56 minus 1x, so that will give us this positive 55x here. And then last times last will be 7 times negative 1. So that looks correct. You use whatever method you feel comfortable with to factor that. Okay, so next up, this side is completely factored, and we have 0 over here. We're multiplying these things out and we get 0. That means at least one of these things had to be 0. So really the only two possibilities are either x plus 7 is 0 or 8x minus 1 is 0. It's got to be one of those two. It can't be this minus out here, right, which is essentially a negative 1, because we know that negative 1 is not equal to 0. So that's why I didn't really worry about that. It had to be this or this that's 0. And then solve those out. I get x equals negative 7 and x equals 1/8 when I do that. Okay? So these are the possible critical numbers. All right. And what you need to do then after that is to take all of those possible critical numbers and put them on a number line that represents the domain of f prime. Okay. I just noticed I left a prime off over here. So let me go back and fix that. Sometimes when I make little marks like that on this iPad that I'm using, it doesn't show up and I don't notice it. So okay, so take your possible critical numbers and put them on a number line that represents the domain of the derivative. So the derivative is a quadratic function. Quadratic functions, their domain is all real numbers. All right, so that's what that looks like. And I need to take those possible critical numbers, which are negative 7 and positive 1/8, and put those on the number line. Make sure that you respect, right, the order of the number line. Bigger things go on the right, smaller things go on the left. Okay. At this point, it's a good idea to stop and classify your possible critical numbers as critical numbers or not. Remember, for a possible critical number to be a critical number, it has to be in the domain of the original function, which is all real numbers. So that means that negative 7 is a critical number and positive 1/8 is also a critical number. So that's a good idea to do that. All right, next up is what you want to do is on each one of these pieces, your possible critical numbers are going to divide your domain of f prime up into some number of pieces. In this case, it's 3 pieces. This piece over here, this piece here, and this piece here. On each one of those pieces, pick a test number. So on this piece, I'm going to pick number 1. On this piece here, I'm going to pick 0. And on this piece over here, I'm going to pick -8. Okay. The reason why we're doing that is because on each piece, right, it's all or nothing, right? Either every number is the solution on this piece to this inequality, or none of them are. Okay, and so we can figure out whether it's all or none by just testing a point on each. Okay. All right, so I'm going to take these test numbers and I'm going to plug them back into this original inequality. All right, so that is -8x squared minus 55x plus 7 greater than 0. Okay, so starting out with a 1, when I plug a 1 in there, I get -8 minus 55 plus 7, which is a -56. Okay. So -56 greater than 0 is a false statement. That is not true. So that means that 1 is not a solution of this inequality. Okay, this one right here. And that also means that none of these numbers on this piece are solutions. Okay, so we know that none of these are solutions. So what that means is that if they're not greater than 0, that when you plug the numbers into the derivative over here, you must get a negative number. And in fact, that is true, right? Every number on this piece over here to the right of 1/8, when I plug that in to the derivative, I am going to get a negative number. Okay, so I like to put a big minus sign right over my test point, because it's not really the test point that I care about. What I really care about is when I plug these numbers into the derivative, do I get a positive or negative number? This tells me that I get a negative number. All right, next up, I am going to plug in that 0 into that same inequality. I get -8 times 0 squared minus 55 times 0 plus 7, greater than 0. So this is 0, this is 0, so I just get 7 is greater than 0. All right, so here I get a plus, right? Number 7 is greater than 0, that's true. That means 0 is a solution to this inequality right here. And that means that every number on this piece is a solution to that inequality. And so therefore, when I plug any number in between -7 and 1/8 into the derivative, I will get a positive number output. And so the derivative is positive there. All right, so I put a big plus over there. And likewise, I'll need to test -8 in there. All right, so when I plug in the -8, in order to avoid doing some other computations in my head, just to make it a little easier, I'm going to show you just a little secret right here. Here I have this -8x squared minus 55x plus 7. If you follow these steps down, you'll notice that this expression right here is exactly the same as this one over on the left side. So you can use this one as well to test, and you'll see that the math is a little easier to do. If you have a calculator, you probably don't care, but since I'm not using a calculator right here, then I am going to go ahead and plug it into, I'm going to erase this, into that factored format. Now, when you do that, you do have to be a little bit careful, because you know, it has to be exactly equivalent to this. If you multiply, like say in the process here, if you multiply both sides by a negative and got rid of that, then that's going to affect this. It has to be exactly the same. In other words, when you expand this out, it has to match this exactly. So this, you can make a mistake fairly easily if you're doing what I show you here, especially with these negative signs or if you factored stuff out. But it's just easier to plug a negative 8 into this. Than it is in this into the original and have a lot of large numbers in there. All right, so here I get negative 8 plus 7, that's negative 1. 8 times negative 8 would be negative 64. Minus 1 would give me negative 65. Multiplying this all out, I get 65 is greater than 0. Okay, or negative 65 rather. Right, negative of negative 1 would be a positive 1, and a positive 1 times negative 65 is negative 65. Okay. All right, so that gives me a minus over here on this last piece. All right, so I have this little sign diagram generated. That is going to tell me exactly how to or where the function is increasing and where it's decreasing. Okay. All right, so I'm going to make a little room here on this. All right, so now for the answer for increasing, so remember the function is going to be increasing where the derivative is positive, right? And so it's wherever I have a plus on my sign diagram, and it's going to be negative 7 to 1, oops, that's positive 1/8. Right here. Okay, so this function is increasing on that interval. All right, and then it's going to be decreasing, right, where there is a negative sign. All right, and so it's going to be decreasing on this piece over here to the left of negative 7. So that would be from negative infinity to negative 7. And then it's going to be decreasing on this piece over here to the right of 1/8. So that's going to be 1/8 to positive infinity on that one. Okay, so there are your answers for increasing and decreasing. Now there's a couple things I need to mention about the endpoints. Depending on how in our class we're just going to make these leave these as parentheses. If you'll notice, all of the answers that are on the quizzes, right, they all have parentheses in there. I just prefer it that way because then I don't have to get into the issues about technicalities as to whether it should be a parenthesis or a bracket. So in our class, just go ahead and leave all of those as parentheses and you'll be fine. Now, if you're in another class, right, then you would probably see some brackets, right, on this, on the endpoints here, and some brackets here and brackets here. A lot of that, right, you're going to have to go with your teacher and what they say about that. I notice like books aren't consistent about it. and it just varies. Okay, so I just wanted to let you know that. Just be careful about that. Depending if you're in another class, right, you might see brackets on here, and if you're a student in my class, then just leave these as parentheses. That's fine. All right, that's it for this one.